Good morning, dear students. Hope you are doing good, and wherever you are, I'm sincerely requesting you stay safe. Situations are not favorable to us. Okay, today we are going to discuss the next topic, the previous topic. See, when we have a look over there, before over there in the topics what we have discussed, see that is nothing but water demand. See, water is in demand, and you know all the activities you have to have the water at least 135 liters per day per capita. Okay, and also we have seen all various types of water demand, and what is the basic what is the quantity that is required, what is the quantity that is required. Of course, that is 135 liters per day, and when we made an attempt, or else that has been bifurcated like this: drinking 5 liters, cooking 5 liters, bathing 55 liters, washing clothes, cleaning floors, cleaning dishes, flushing purpose. That's what all we have seen. See, to that, an associated topic we have seen, that is estimation of water demand. See, for that, it's estimation of water demand. See here, this is what I mean already we discussed. So the storage capacity of reservoir. The topic is what I want to ponder now is storage capacity of reservoir. See, we discuss the storage capacity of reservoir and what all the different precautions that we should take. We have discussed, and the formula that we will adopt at the time of storage capacity estimation also we discussed. Now we entered a topic which is closely associated to the storage capacity of reservoir, which is supposed to be there itself. We're supposed to discuss there itself, but we are discussing now as it is some derivative part, mathematical part. See here, when we have a look the topic what we discussed in the previous class about this mass curve method. See here, the mass curve method. We were started this mass curve method yesterday. So keep in mind, when we may get a question, by giving this particular data, and it is for 24-hour pumping, and it is for 24 hours pumping. And here, this is the data what we have. See, of course, this data will be given to you in the examination, and we may ask, when we may get a question, find out the storage capacity of reservoir by using mass curve method. Here the formula is S equal to EP plus ED, where EP maximum excess of maximum or else excessive pumping. In one word, ED is excessive demand, whereas S is required storage capacity. Right? See here, these two columns we got that we have, and it is a pre-given data, and from this given data we are developing, we are trying to solve to reach in the name of finding storage capacity. See here, the third column how we got, simply one empirical formula is there to get hourly demand. The hourly demand liters can be calculated by multiplying it by 60. See, 8 into 60, 4,80,000. 9,000 into 60. That means here, like that, we have the values of this third column. Up to here, we discussed yesterday itself. Understand? See, are you with me now? Please listen carefully. The data about this time and this average hourly demand that will be given to you, and and they may ask you find out the storage capacity of reservoir. Understand? See how we got this data? Simply by multiplying with 60. Why 60? It is an empirical formula. So to get the hourly demand, 60 here. See here, see per minutes. Now it is the we are given average hourly demand per minutes. See here now we are getting hourly demand. That is the result 60. See here by multiplying it by 60. See here hourly demand. See by minutes per minute 8,000 per hour 4 lakhs 80,000. Understand? Now after hourly demand there is a column which we are going to find out column values, that is see here 4 lakhs 80,000 cumulative. By the time we reach to 2 o'clock, the total amount of water that is demand is, we must sum up the water that is required at 2 o'clock and also the water that is required at 1 o'clock. Understand? So by see cumulative demand, by adding these two, the values are, see, try take the cals and add these two. 48, 54, 102. Understand? 48 and 54. What it is? 102. And same way, to this 102, you must add this 63 also. So this, you should add this 66, then 63. Then you'll get 1.65. Or else 165. Add one to this 165. See, to this 165, add this 66. How much is? Simply 231. I'm just, reading all these three values only, not here valuing the zeros and not giving exact number, because for easy remembering, I just reading these values only. Likewise, we got the cumulative demand. Understand? How we got hourly demand? It is per minute, per hours by 60. So it is hourly demand. The cumulative demand is simply adding 102. 48 plus 54, 102. 102 plus 63, 164. 165 plus 66, 231. Likewise, we got the information about cumulative demand. Now we must find out average hourly demand. That means minus hourly demand. That means here one sum is there here, or else one derivation is there. One problem is solved. What it is? Average. See, total 24 hours, how much of water is required? This is what the amount of water that is required. By 24, we are getting average. By 24 in the sense 24 hours. Why 24 hours? The problem is asking for 24 hours pumping. That is the reason by 24. How much we got? 8,96,250 liters per hour on average we need. Understand? See here now. Here, so, here this has to come here. But see here, one column taken. See here, this value has to project here. But this is somewhat while we are converting, while we are adding the information. See here, keep in mind the 416 has to come here. See one column above. Unfortunately, that these values are projected here. Please take correction. See here, up to here, the 416250 is here. See why? What is it? Is average hourly demand minus hourly demand. What is hourly demand here? 4,80,000. What is the average hourly demand? 8,96250 minus 48. How much we got? 416. Understand? Now, see, and it is 3750. That means excessive pumping. See, what is hourly demand here? 90,000. 9 lakhs. Sorry, 9 lakhs. What is the required? 8 lakhs. What is average? 8 lakhs 96,250. That means average required water is 8 lakhs 96,250, but demand is 9 lakhs. That means again still we should have 3750 liters. Understand how we got it? 3750. Have a look. The required average is 8,96,250. But that demand is, we have an average of 8,96,250, but required is 9 lakhs. Understand? We have an average pumping 8,96,250, but demand is at 6 o'clock 9 lakhs. That means still we need 3,750 liters. Understand? See, average pumping. See here, this is pumping. Average pumping. What is average pumping? In what is the need of, what is the average pumping that we need is 8,96,250. But what is the demand here? 9 lakhs. And what we should do, so the pumping is 8,96,250 and the demand is 9 lakhs. So still we are in demand. We are in need of 3,750. Understand? See here, excess still in need, excess demand is still, and excess pumping is here. See, the average, the pumping is 8,96,250, but the demand only 4,80,000. So the remaining is excessive pumping. This is excess demand and it is excess pumping. Understand? See, excess pumping. See here in this column I just mentioned 416,250. 416,250. Understand? See here. Likewise, see here the required average pumping that is needed is 8,96,250, but the demand is 10,20,000. So still in demand of 3,33,750. Understand how we got this column? Simply average hourly demand minus average hourly demand is this one minus hourly demand. That means column 3. Likewise, we got this is excess demand and this is excess pumping. Now we sum up. This is the value we got. When we add this column, the total is this amount. One more time. See here how we got this third column into 60. Why? It is in minutes. Now we are converting into hour, 60 minutes. This is what we got. Cumulative demand. We are adding these two values. 2 o'clock, one total amount that is required 10,20,000. By the time we reach to 3 o'clock, that is total required is 16,50,000. Understand? Likewise, this is excessive demand. The average pumping is 8,96,250 and average required is 9 lakhs. Still we are in need of 3,750 liters. Understand? This is what about the these three columns now we form. We have to find out the storage capacity of reservoir. We need to find first of all average pumping that is required, and after that, see here hourly pumping required is 8,92,650 and cumulative pumping. In the previous chart, we have seen cumulative demand. Now is cumulative pumping. See how much? 8,92,50 and we are just pumping. See, you are adding 8,989. Understand? Likewise, we are adding. This is what about cumulative pumping. Now, excess demand. See here, cumulative. See, hourly demand is 12 lakhs. See here, cumulative demand is this amount. See here, 12 lakhs 9,000 hourly demand. See here, it is excess demand. How much we have? Pumping is 8,92,650. How much still we need? See, approximately 9. Understand? Still we need 1,31,250 excess demand. See here, 3 minus 5. Column 3 minus 5. See here, column 3, what it is? 99,90,000. Understand? And minus, this is cumulative pumping. 98,58,58,750. Still in demand is 1,31,250. That means that cumulative demand minus cumulative pumping. How we are getting cumulative pumping? Simply by adding these two. Whereas in the cumulative demand by adding these two. Understand? See here, still in demand is 1,31,250. Excessive pumping now. See here, 5 minus 3. This is cumulative pumping minus 3 cumulative demand. See here, this is what? From 8,92,650 minus demand is, cumulative demand is 4,80,000. Now we got, this is the figures, the excess pumping. That means the total day, the excessive pumping is at 5 o'clock. That excess pumping is, see here, 14,51,250. In the total 24 hours at 9 o'clock, the demand is 8,20,000. Excess demand is 28,750. What is the demand? What is the solution to find out the storage capacity? Simply, yes, storage capacity equal excessive demand plus excessive pumping. What is excessive demand? 8,28,750. What is excessive pumping? See here, 14,51,250. This is about the required storage capacity. We need to find out cumulative demand, hourly demand, and average hourly demand. See excessive pumping and excessive demand, and also cumulative demand and cumulative pumping. Once we got these two values, automatically we'll give the data about the required storage capacity. Now we'll see a graph here. See here, all the values what we have. This is a flow in million liters, and this is the time for 24 hours. At 2 o'clock, see here from curve C to D. I mentioned here the mass demand curve CAB in thick line. See here CAB, CAB. This is the curve. See here, the steepness of mass curve indicates high rate of demand. Steepness. See here, this is the pumping, excessive pumping, excessive demand, steepness. This is the demand, excessive demand. Actually, what we need? This is we need CD, but here the pumping is, demand is less. See at 4 o'clock, the demand is, see the figure at 4 a.m. The 4 a.m. the required pumping is 2 lakhs and 23 lakhs 10,000. See here at 4 o'clock, see here 23 lakhs like this. At 6 a.m. the pumping is, see here at 6 a.m. have a look. At 6 a.m. 39 lakhs 30,000. 13 at 6 a.m. See here 39. Likewise, all the values you are plotting on a graph, once we plot it, we'll get this graph. Like this we'll get. This is cumulative pumping, the straight line. See here, now the curve indicates the storage capacity. See here at a particular point, that means at 5 o'clock, we have an excessive point, excessive pumping. See here, at 5 o'clock, excessive pumping is there. That means the water is flowing off. The pumping is more than the demand. Understand? But whereas by the time to reach, see, to reach at 9 p.m. 9 p.m. the demand is, see here, 8, 9. See, that means 9 p.m. 8287, 8,28,750. See, 9 p.m. 9 p.m. in the sense 21. See here, that means the supply is this one. And pumping is, the excess pumping is, excess water is here. Once we calculated this, these values, the pumping extra water is found at 5 o'clock. But excess demand is found at 9 o'clock. That means the excessive pumping is 1.45 plus excessive demand 0.83. See, as we are, it is million liters, it is liters. When we are converting, see that see here, 82750 to million liters, we'll get the 0.83. Whereas the same we will get when we are converting 14,51,250 into million liters, that is 1.45. The required is 2.28 in the graphical method. Whereas in the problem, in this method, numerical method, this is what answer. The same is representing on the curve. The same is represent the values whatever we got here. The same is representing here in the graph mass curve method. Understand? What is 0.83? This is 0.83. 82. See, just we are here. We summed up. I mean, we closed because the value is very close to 83. That is the reason we just summed up 0.83. See, the value is 8,28,750. We just summed up into 83 lakhs. Sorry, 8,30,000. See here, 8 lakhs that we just convert into million liters. That is the reason 0.83. Here 1.45. Here this is 18 lakhs. This is 14 lakhs. That is why 1.45. Total is 2.28. Here also we got 2.28. Understand? The same value is projecting on the graph. This is about mass curve. That the same thing I wrote here. The steepness of mass curve indicates high rate of demands. See here, this is what? Steepness. And next point is here. The C line CD is the line indicating cumulative pumping at uniform rate. See here, pumping, cumulative pumping. Here the water is flowing off because that required is only. See here at 5 o'clock, required is only is cumulative pumping. 3 lakh, I mean, see here, required is only, we see here. Here at 5 o'clock, required hourly pump, cumulative, I mean, pumping is required. See here, cumulative demand is 30, 30 lakhs, 30,000. That is the reason we mentioned here. And this is the amount of water that is flowing off. Whereas the water is required still than the pumping. That is why we are just adding 1.45 and 0.83. See here, that's what I mentioned here. That to determine the required storage capacity, draw tangents to lowest point A and highest point B. See here, to lowest point A and highest point B, tangents. Draw a line, a tangent, and this gives the required. See 1.45 and 0.8. That's what I mentioned here. The highest vertical distance between B between the two tangents that give the required capacity of the reservoir. This is because at 6 a.m. there is excess supply equal to A dash. That is 5 o'clock, and BBC in the other words that is SE equal to EP plus ED. Simply at 6 o'clock, see 1 point. Of course at 4. At 5 o'clock I mentioned, not 6 o'clock here. At 5 o'clock, see here, that is excessive pumping. That's what I mentioned here about this graph. Simply we are adding at 9 o'clock and at 6 o'clock, 5 o'clock, 1.45. This is about the mass curve method. Understand? Hope you understood. Again, one more time. See here, this is the data what you got. You may get it. After that, we must find out hourly demand. It is in liters. You're just adding into 60. We got this hourly demand. Then after that, cumulative demand. See, average hourly demand minus hourly demand. This is excessive demand. The remaining water will be here. And this is excessive pumping. You got it. And after that, you need to find out average hourly demand. Of course, the same. These two are the same. But here I mentioned it just to 60. These two are same. See here, slides, excessive demand and excessive pumping. Simply, now we are finding out cumulative pumping and cumulative demand to find out the excessive demand and excessive pumping. Here at 5 o'clock, we got the excessive pumping. At 9 o'clock, we got the excessive demand. This is the problematic solution, and this is the graph. Now, if the topic is at 6 a.m. to 6 p.m., that means 12 hours. See, in the previous case, we have seen the 24 hours. Now the problem is at 12 hours. The same data, if you go for 12 hours from 6 a.m. to 6 p.m., how we can find out? Simply the same value, hourly demand and hourly cumulative demand. See here, only up to 6 to 6 we will find out. That is what I mentioned here, 6 o'clock. Okay, here 6 o'clock. At 6 o'clock, excess demand. We are only looking for after 6 to 6. Understand? At 6 o'clock, hourly pumping is why? Because In the previous instance, we got the average by 24. Understand? By 24 here, because it is 24 hours. Now we will get an average hourly pumping by 12. Simply by 12, how much will get it? 1 point. See 17 lakhs 2000. See 1 lakh 72,950. This is hourly pump. Have a look here. This is by 12. The value will get it when you go with by 12 or 6 o'clock. This is the average hourly pumping, and cumulative pumping obviously by see hourly pumping. Yes, this is average needed hourly pumping. Here the same column we have seen here also. This is hourly pumping because it is for 24 hours and it is for 12 hours. That is the reason 6 a.m. to 6 p.m. Now cumulative pumping 1.7 to see 70 1,72,950 plus 1,72,950. This is the cumulative, and up to here, this is the cumulative, and the same will continue up to here also. Here now, excessive demand, how will get 3 minus 5 at 3 o'clock and minus 5. This is the excessive demand. The highest excessive demand will get it at 6 o'clock. At the same time, excessive pumping will get it at 6 p.m. Understand? This is about when we ask a question, when you get a question for 12 hours, you need to go for only, and they may give an timings also 6 a.m. to 6 p.m. How we get this data? By 12. Understand? Hourly pumping, how we got it? 1,72,950. How we get the same way like we got in the previous problem. See 8,92,650. How we got this? By 24. When we go for by 12. See here by 12, 2151 by 12, you get this data. Understand? There the same, this answer by 24, 21510 by 24 you get it this one. By 12 you'll get the answer this one. See, this is the cumulative pumping, and here you get the same data. See, mean 3 minus cumulative. How will you get the excessive demand? Simply 3 minus 5. Understand? This is what about the information. This is already there. The cumulative demand 3,92,000. Excessive demand at 6 o'clock. Now excessive pumping is at 6 p.m. Understand? This is about the information. Excess demand is 3,93,000, and the same is 39,30,000. Max excessive pumping is 48. Of course, 48 lakhs. And then S is equal to ED plus CP, 8.73 million liters. This is required storage. Understand? This is about the finding of storage capacity for 12 hours. Hope you got the information. For 12 hours, simply the sum of cumulative demand by 12 hours. This is the value you'll get. Understand? By 24, you'll get it. This is the value. You'll get it. And simply, you'll put it here, hourly pumping. Here, you're just simply mentioning here as it is the by 12 here. And cumulative pumping in the previous case, likewise, cumulative pumping you have seen for 24 hours. This is cumulative pumping. In the same way, here also, cumulative pumping for 12 hours. Understand? Like this, we'll find out the storage capacity of reservoir. See, definitely, I'm sure when we go for offline classes, once they started, the graph out, we'll go for different methods of these type of problems. But this is just an example how we'll put it on graph and how we'll go for problematic solution. Understand? The figures, the values. This is about mass curve method. So definitely in the offline classes, we'll go for different models and we'll discuss different examples. There we'll definitely learn more elaborately. And this is the basic process to find out the storage capacity of reservoir. Once we go for offline classes, definitely we'll go for we'll practice this mass curve storage. Finding of storage capacity by mass curve method with the different examples. Okay, thank you. If any doubts, please make a call or else give me a mail or message. Thank you.